Hey guys, in this video we use Microsoft Excel to model projectile motion and calculate some key quantities. Okay, so let's get started. So first of all, what we want to do is we want to set up our input cells. Now while you're watching this video, feel free to pause it, rewind and go back over a section if you need to see what was done in a bit more detail. Okay, so here I'm putting in the key quantities of initial velocity, launch angle, launch height and acceleration, and then quickly doing some formatting just to make it look a little bit neater. So I always like to add borders around my cells, and I also like to shade in my input quantities in a different color so I can see where I need to type information in to be able to change my model. Always make sure you put in things like units here as well. And one odd thing in Excel is we need degrees to be converted into radians for the calculations. Sine, cos and tan in Excel uses radians, so I've added that extra column there of launch angle so that that calculation can be done. Now we're going to convert our input information into some useful things. So we need initial x velocity and initial y velocity, and for something else later on, I'm also adding change in y displacement. Now again, I'm just going to do some quick formatting here just so that it's nice and neat and I can see what's going on my spreadsheet. Now here I'm using blue to show the cells where a calculation is being done by Excel rather than an input calculation. When you do calculations in Excel, first of all, press equals. And once you've done that, just remember the differences between that and your formulas. So times is the little star symbol, divide is the little / symbol. Now, hopefully you know where the formulas come from, but I've also put on the screen just a little snapshot of where you can work out where the formulas do come from. You'll notice that as I enter the information for the formulas, it highlights the cell that the data is coming from. Always make sure that you are getting the data from the correct cell. Okay, here I'm putting in equals radians, and that's the function in Excel to convert the launch angle in degrees into radians for those later calculations. Always make sure you've got units, don't forget to add them in. All right, now I'm doing my main calculation. So again, I'm going to type in the quantities, max height, time of flight, final velocity, horizontal range, final x velocity, final y velocity, final velocity angle, which is the angle that it crashes at. And I'm doing that twice because one will be in radians, one will be in angle. Doing some quick formatting, adding in my units, and we start doing our formulas. So again, I'm just flashing up the formulas here on the screen for you. Hopefully you know where they come from. Feel free to pause and have a look at what I've typed in so you can copy that into your own Microsoft Excel spreadsheet. Just be aware that where I say something like B5, I'm referring to a cell. It might be different on your spreadsheet unless you've typed in everything in the exact same spot that I have. Now here, max height is above the start position, and that's just comes from where I've worked it out mathematically. Adding to that the height above, the start height above ground will give me the max height above the ground. So just a little calculation there. With some of these more complicated formulas, it's always good. It is always a good idea to use brackets around things just to make sure that it is calculating the way you want it to. Here, everything is divided by gravity, so I need to bracket everything on top. So that's the minus uy plus the square root of uy squared minus 2gc. It needs to all be bracketed and then divided by gravity at the end. You see that I'm closing the bracket, and then lastly dividing by, and I click on the acceleration due to gravity minus 9.8 to put that into the equation. One thing I like to do as well when I'm starting to put these calculations in is to put in some values in my input data, so my initial velocity, launch height and acceleration, just so that I can see the calculations actually doing something and I can test these calculations out and make sure they're actually doing what they're supposed to. Now here, I actually have typed in a different formula for range than what I'm showing you on the screen. I strongly recommend you use Sx equals uxt because it will actually work for any situation, whereas the formula I used won't work for everything, unfortunately. Now again, Excel produces or works with angles in radians. So we do that final conversion to get back from radians back to degrees, and we have ourselves our final answer. So now we've done our calculations, what we want to do is create a model using a graph. So I'm entering time in here and then clicking on that little right hand bottom corner square to drag it down. Probably don't need that much time, but it's always good to go further than you need. Now I'm entering a formula that's going to calculate the x position for each of those times. Now it's important that you do use dollar signs to make absolute references to things that don't change. Here, double clicking will drag that down. You'll see if you pause it, will show when I show the formula there that it's looking at the time in the cell next to it, but it's going back to ux each time to get that value, and the dollar signs lock it to it. And again here, I need to use dollar signs to lock things like acceleration, uy, and the launch height to make sure that the formula always goes back to those exact cells to get that number. As you drop the formula down, it's going to get the different times, so 0.1, 0.2, 0.3, based on what's next to it. And it's going to work out the y position for us based on that time. So double click that little square, drops the whole lot of formulas down. And now we have our x and y positions for our formula based on the input data. So now we can go up to insert and we want the XY scatter graph there. This one I'm clicking on here is good because it doesn't have any, doesn't show the data points, so we get a nice smooth curve. It looks a little bit better for this. And what we want to do is just change the input data so it only goes down to where y equals 0. So change it for x and y. And what that does is it stops the graph where it crosses the x-axis. And you can see that there. We now have ourselves quite a nice looking graph. If you do change some input data, you may need to change the where the chart is getting its data from, just so that you rescale it so it looks nice. And there is a model of our projectile. We can see the trajectory of the projectile based on the input data that we've put into Microsoft Excel. Lastly, we just want to quickly format the numbers. What I'm doing here is just formatting the cell and selecting 2 decimal places just so that it displays nicely. Now we can just change our input data, initial velocity, launch angle, launch height and acceleration, and Excel will take care of the rest. It will tell us what the maximum height of the projectile is, how fast it's traveling when it crashes, and it will even produce a little graph of the trajectory for us. Thanks for watching.